Hello everyone. In this video, I will be explaining Norton's theorem theoretically, and then I will apply it to an electrical circuit so that you can understand that how to obtain the Norton's equivalent of a complicated circuit. So firstly, we have to start with that what the Norton's theorem states. Now according to Norton's theorem, if we are having multiple sources and multiple resistances in the circuit, then that complicated circuit can be replaced by an equivalent current source in parallel with the e- equivalent resistance across the load terminals. So it's a bit similar to the Thevenin's theorem, in which we used to replace the complicated circuit except the load resistance by a single voltage source in series with single current source. But in case of Norton theorem, instead of voltage source, we have current source. Instead of connecting that resistance in series, in this case, we will connect the resistance in parallel across the load terminals. So reason is again same, that why we go for the Norton theorem equivalent, because we can simplify the circuit to a simple current source and a single resistance. So that will be a quite simple circuit, and after that we can find out the current through the load resistance. Now let's take the example of a circuit. Let's say we have this circuit. Here we have resistance R3. These are the terminals which are load terminals, where we are connecting the resistance. Now according to Norton's theorem, except this RL, the whole circuit can be replaced by a single current source whose value is written as IN, and it's connected in parallel with single resistance Rn across the load terminals, that is AB, and then we will connect the load resistance back over here. And if we have to find out the current through this load resistance, then it can be found by current division rule. Now the source current is IN, opposite branch resistance is Rn, and in denominator we will have Rn plus RL, that is the load current. So question is, what is IN? IN is short circuit current through load terminals. Short circuit current through load terminals means the load terminals, they are to be replaced by a short circuit, and then we will calculate that what is the current through that. Rn is equivalent resistance seen from load terminals. The equivalent resistance seen from load terminals, how to calculate this? That if we have any independent voltage source, we can replace that by short circuit, and if we have any independent current source, that current source will be replaced by open circuit. And if we have dependent source, in that case we can't replace them by open circuit and short circuit. The methodology is different, that I will discuss in the coming videos. So basically this Rn is same as RTh. Procedure is also same. Like in this case, we have resistance R1, voltage source V1 replaced by short circuit. Then we have resistance R2, source V2 again replaced by short circuit. Here we have resistance R3, load terminals A, B, and here we will calculate Rn. So Rn will be R1 and R2, they are in parallel and it's in series with R3. So it's a parallel combination of two resistances and then it's in series with that parallel combination is in series with R3. It's very simple in this case. Then we have to find out the short circuit current. Now to find out short circuit current, what will we do? We have the circuit like this. These are the load terminals A, B, R1, R2. Now load resistance is to be replaced by short circuit. Then we will calculate the value of short circuit current. Now how to find out short circuit current? It's our choice. We can go with mesh analysis. We can assign current I1, I2, then ISC is same as I2. For finding I2, we need to write two equations, mesh 1 and mesh 2. So if I write the equation of mesh 1, then it's minus V plus R1 into I1 plus R2 into I1 minus I2 plus V2 equal to 0. So mesh 1 equation. Mesh 2 equation is drop across R3, R2 into I2 minus V2 plus R2 into I2 minus I1. So we can solve these two equations simultaneously to get the value I2 and that is the value of ISC. ISC is basically Norton current because this is Norton current is short circuit current. Or you can also solve it by using nodal analysis. So if we go with nodal analysis, then ISC is equal to V upon R3. We need to find out the value of V by applying KCL at this node. Then the equation will be V minus V1 by R1 plus V minus V2 by R2 plus V by R3 equal to 0. Only one unknown, you can find out the value of V from here and then you can have the value of ISC. So you can choose a method in which you feel that you are comfortable, you will get the answer right. So how to find out ISC? We don't have any particular formula. What we need to do, we need to short circuit the load terminals and then we need to find out the current. Then you can apply any method whichever is suitable to the problem. You also need to check that which method is giving us the solution in minimum number of steps so that we don't waste so much time in calculations only. Now to understand this Norton's theorem better, let's take the example of an electrical circuit in which we need to find the current through 10 ohm resistance using Norton's theorem. Now what is there in the circuit? Different sources and resistances. This resistance is actually load resistance, which is 10 ohm. Now we have to find two things, then after that we will have the Norton's equivalent. First is calculate ISC. For calculating ISC, let me draw the circuit again. You always need to keep in mind that draw the circuit again. Don't go with the only this circuit. Don't go with your imagination that if we short circuit this, then how the circuit is getting modified. It's always better to draw the circuit again and again in order to avoid any mistake. We have to find out the current over here. Now I have two choices. I can solve this with mesh analysis. I can solve it with nodal analysis. If I solve it with mesh analysis, then I have to assign two mesh currents, mesh 1, mesh 2. Then I need to solve two mesh equations. And if I go with nodal analysis, there are two nodes out of which one has to be reference, and to the other one I can assign the voltage. And then I have to solve just one equation. So in this case, I will prefer nodal analysis because it's a so we need to solve only one equation. So when we apply nodal analysis, current in this 5 ohm resistance V minus 20 by 5, then current in 2 ohm resistance V by 2. Current through this 8 ohm resistance is V minus 12 by 8 equal to 0. So you have single equation V by 5 V by 2 plus V by 8 equal to 20 by 5 plus 12 by 8. The solution of this will give us the value of V as 6.67 volts. Now ISC is short circuit is in series with 8 ohm resistance. So what is the current through 8 ohm resistance? Same is the short circuit current. ISC is V minus 12 upon 8. So it's 6.67 minus 12 by 8 minus 0.667 amperes. Now as per our assumption, the short circuit current that is flowing from A to B, but since the sign is coming as negative over here, so actually its direction is like upward. So we will draw the Norton's equivalent accordingly. Second step is we have to calculate Rn. The procedure for calculating Norton's resistance is same as Thevenin resistance. We will replace this 20 volt source by short circuit, 12 volt by short circuit. Load resistance has to be removed from the circuit and then calculate the equivalent resistance. 20 volt source replaced by short circuit, 5 ohm resistance, then we have 2 ohm resistance in this branch, 8 ohm, and this 12 volt again replaced by short circuit. Here we have terminal A and B. This is Rn. So Rn is 5 in parallel with 2, and this parallel combination is in series with 8. Rn 9.43 ohm. So once we have this equivalent, then we'll calculate. So we will draw the Norton's equivalent. 9.43 ohm resistance. Here we have A and B, where we have to connect 10 ohm resistance. Since the current has to flow in upward direction in this one, so this current source must be in this direction. That was the meaning of current coming as negative. So we will show the current source that it is supplying the current in downward direction, so that through the load terminals current will flow from B to A. Now the question was to find out current through 10 ohm resistance. It will be source current into opposite branch resistance, that is Rn 9.43, and in denominator Rn plus RL, and answer is 0.324 ampere and it's in upward direction. I am taking one more example of Norton's theorem in this video and take few more problems in the next video. In second problem, again we need to find the current through a resistance of value 8 ohm using Norton's theorem. Now the circuit is having a current source as well in addition to the voltage source. Then we have another current source over here, and here we have 8 ohm resistance. So this is not 15 ohm, this one is 12 ohm. Now we have to, in first step we need to calculate IN, or we say ISC, short circuit current. So when we have to calculate short circuit current, we have 5 ampere source, 12 ohm resistance, 5 volt, 4 ohm, 2 ampere, and then we have the terminals of load resistance, and it has to be replaced by short circuit. We need to find out the current over here. Now what we see, that this short circuit, it's in parallel with 4 ohm resistance. So when we have any resistance connected in parallel with short circuit, that resistance actually gets short circuited. So what will happen? This circuit will be modified to 5 ampere, 12 ohm, 5 volt, 2 ampere, and here we have short circuit. So this is our simplified circuit now. Sorry, not simplified, the modified circuit. We have to find out ISC. In order to find ISC, if I use a circuit as it is, and then I want to apply mesh analysis, then from here I have first mesh, second and third. We have 3 meshes. Now this circuit can be simplified furthermore by changing this current source to a voltage source. We have a current source of 5 ampere connected in parallel with 12 ohm. So basically it's a practical current source which can be changed to a practical voltage source. We can apply source transformation over here. So when we apply source transformation, the voltage value is 12 into 5, 60 volts. Arrowhead replaced by positive terminal, arrow tail replaced by negative terminal. 12 ohm is to be connected in series. Then we have 5 volt source, 2 ampere. Then we have ISC. Now in this case we can't go with the nodal analysis. You might have thought that we could have applied nodal analysis in this case by considering this as reference first node and second node, but it's not applicable since we don't have any resistance over here. In this branch, the resistance is actually 0. So when resistance is actually 0, that means current through that branch should be infinite, which is practically not possible. So we need to find out the current by using mesh analysis. So when we apply mesh analysis, so here we will have current, we can say I1, here current is I2. So it's a case of super mesh. We have to start with the 60-volt source, minus 60 plus drop across 12 ohm plus 12 I1 plus 5, then we don't have any drop over here, equal to 0. So that will give us the value of I1 as 55 by 12 is 4.583. So this is the value of I1. And we need to find the value of I2. From where we can have the value of I2? We can calculate it by writing the constraint equation. The constraint equation will be I2 minus I1, that should be equal to 2. You just need to write this one as I1. This one is I1. So I2 minus I1 is 2. I2 is 2 plus I1. So I2 is 6.583 ampere, which is actually the value of short circuit current. So the Norton's equivalent for this circuit is 6.83 amperes in parallel with Norton resistance, and here we will have 8 ohm resistance. Now we need to calculate R Norton as well. Let's calculate that first. For calculating Rn, 5 ampere current source, it should be replaced by open circuit. 5 volt replaced by short circuit. 2 ampere replaced by open circuit, and load resistance again replaced by open circuit. So we have an open circuit over here, then 12 ohm resistance, this voltage source replaced by short circuit, 4 ohm resistance, 2 ampere source replaced by open circuit, and then here we have the load terminals where we need to calculate Rn. Now clearly 12 and 4, they are in parallel. So Rn is parallel combination of 12 and 4, which will give us the value of Rn as 3 ohm. We want to find out the current through this 8 ohm resistance. So I8 ohm is 6.583 into 3, in denominator 3 plus 8, which gives us the answer of current through 8 ohm resistance as 1.795 ampere. Now one thing we need to keep in mind, that now we have drawn this current source in upward direction. The reason was we had assumed that the short circuit current, that is the current through this load, these load terminals, is flowing in downward direction. So if we want the current through load terminals in downward direction, let's say from A to B, then the current source must have this direction. So I think these two problems have shown two different directions of current source, and you are able to understand that why we are drawing the current source in upward direction and why we are drawing it in downward direction. In next video, I will solve a few more problems on Norton's theorem. which will have the circuits a bit complicated than these two. So I thank you all for watching this video, and if you feel that this channel is helpful to you, then please consider subscribing it.